Today we're going to talk about the TMC2209 and how to configure it for UART. Now I need to point out a couple of things on the board. This is the default position for the jumpers on the board for our steppers over here. Now our steppers are our X stepper, our Y stepper, our Z stepper, our E0 stepper, and our E1 stepper. Now, a couple of things that I'll tell you about right off the bat. With the TMC2209, you're able to use these two pins over here in order to control the current as well as the overcurrent for your NStop. Here's an extreme close-up of the TMC2209 version 1.2. Now I need to point out a couple of things on the top side so you'll know how this operates. First of all, we have a trim pod right here. That's used to adjust the current going to the board like a faucet electronically. But it's a physical faucet that we can turn. We're not going to need this for the TMC2209 for UART, but I do have to point out that we have some pins that we need to be aware of. Over here we have our enable pin. That's used to align it correctly in the SKR version 1.4. And we also have another pin that's of importance, and that's the direction pin right over here. And then some people use the ground as well up in the upper corner here. And over in the center we have our pad for putting our heat fins on top of. And this will be used to actually wick away heat on top of your board. Here's the underside of the TMC2209. Now I need to point out, in addition to the pins, we have jumpers that we have to be aware of. But these jumpers are actually known as 0 ohm resistors. For instance, they have spread cycle down here. If we were to want to change something, we'd have to heat this right here and move it over for spread cycle, but we're not doing a video on that right now. We are doing a video on how to do UART. So you'll have to be aware of the resistor right here, which is a 0 ohm resistor between these two pads. If it's missing, it may cause issues with UART, so keep that in mind. Here's the data sheet for the TMC2209. As you can see over here, it says what the features and benefits of the board are, being that it's a two-phase motor stepper, and it can handle up to 2.8 amps. Now keep in mind, it also has down here the ability with smooth running, or it's by microplayer apparently, of allowing you to get up to 256 of a step. But it can also do a regular step or dir, being direction, of either 8, 16, 32, or 64 micro steps. But we're more interested in just learning how to set it up here. So I'm also going to say that it has Stealth Chop 2, which is for silent motor operation. And then also it has spread cycle mode right here, which will allow you to do highly dynamic motor control, meaning that it can go faster with the use of software. And it has stall guard. And stall guard basically will help you figure out where the end of an axis is, because the current will spike when it reaches the end of an axis. So keep those in mind. Now also, there's a lot more in this data sheet that I'm not describing, and I'm kind of doing it on purpose so that you'll read it yourself and understand what's occurring. So I'm going to get back to showing you how to set up the TMC2209 on the SKR version 1.4, but I have to let you know that no one is paying me or sponsoring me to do a tutorial on this, and I purchased the equipment with my own money, but I will be placing Amazon affiliate links in the description in order to help you find it or offset my costs. Before we can actually hook up the TMC2209, we need to know something about what the jumper settings should be on the SKR version 1.4. So right here, I have the datasheet open for the SKR version 1.4. And as you can see, it says how to set the jumpers right here for each one of the steppers that you'll be using. Now keep that in mind, but also, if you're not doing NStop detection and you're just using it for the stepper, you will need to remove this pin in order to use regular physical NStops. Also, I need to remind you that there may be, at the recording of this video, an issue with NStop detection in Marlin's firmware. I do not know exactly which bug it is, so I'm not going to be showing you how to do NStops in this tutorial. I will be doing it in a future date when they actually fix it in the firmware. So over here, what we need to understand is the Marlin firmware. Now, in order to download it, we're going to go to download, which is at marlinfirmware.org. We're going to click download. And what we're going to do is we're going to download the latest release, which is 2.0.5.3. So I'm going to pull that down. And while that's saving, what I'm going to do is show you some resources that actually exist here. So over here we have tools, and this tells us a little bit about what bugs may be open, so we can go to a bug tracker. Now the bug tracker is useful in that we can search for something that's open for an actual issue. So if we do TMC2209 Sensorless Homing, we can see all the issues that may have been opened in this time. And this may walk you through ways to get around the problem, or that it'll inform you that there's an existing issue that is open. So I'm going to close out of this for a moment. And I'm also going to show you something in help. So help has a couple of things that are useful. For instance, we have troubleshooting, where we can click here, and down at the bottom we have trinamic steppers. This will tell you a lot about your steppers and the settings that you can use. So keep this in mind if you want to learn more about it. You can also go to search and type TMC and press enter, and it'll show you the G codes that we can use. So the one that we're probably going to use the most is going to be M122, just to make sure that we've got it set up correctly. But there's other information in here, such as like trinamic drivers, which will tell you what is supported on each particular trinamic stepper driver. So to prepare the board, what we're going to need to do is we're going to need to pop out these jumpers over here. So I'm using a dental pick to get them out. Okay, now that they're all out of the board, what I'm going to do is I'm going to show you how to actually populate the board correctly for the jumpers. So for TMC2209s, you want to put the jumper there, just like in the directions, and here. Now we're going to pick this up, and they've given us a hint by putting a red row where this needs to go. But we already know about where the enable pin is if we watch the other tutorials. We're going to apply a little bit of thumb pressure to put that in place. And we're going to do the same for this over here. Now keep in mind on the TMC 2209, when you're using an SKR version 1.3, you'll have to move jumpers for NStops, but these will be disabling your X minimum and your Y minimum when they're in place unless you clip off the pin in the directions for the manual. So the next thing we want to do is we want to place our heat sinks on top of here to wick away the heat. And while I'm doing this, I'm also going to explain that what we need to do in order to run these is to have additional cooling, such as a cooling fan. And the rationale for that is these boards are a little bit more expensive than normal, and you don't want to burn them up. But I'll show you where the actual fans are located on the board for power, because we have either 12 or 24 here, 12 or 24 here, 12 or 24 here, and over here we have 12 or 24 volts that we can use depending upon what we use for our power supply. I highly recommend using 12 volts because then other auxiliary equipment that you use will be more useful. But for now, that's how we're going to configure it. Now the next thing that we need to do is we need to connect the USB to the SKR version 1.4 in order to program it. So I'm going to put the big side inside here, and the small side I'm going to connect to the computer, and you may hear a beep, but because I haven't moved this jumper yet, you may not. So I'm going to move this over first before plugging it in. That'll allow us USB power, and now I'm going to connect it. Okay, now that we've actually downloaded and extracted the Marlin firmware, I'm going to show you real quick how you would extract it. You'd right click, and you'd go to extract all and follow the prompts, which will then give you this folder over here. And inside here you have your actual Marlin firmware that we're going to edit. So what I'm going to do is I'm going to first show you what the micro SD card looks like on the SKR version 1.4. As you can see, this is the current date and time. So we're going to open up VS Code. And in order to load the firmware, what we need to do is add the folder. So I'm going to click on Add Folder. And I'm going to go to the Marlin root for the second Marlin. And I'm going to click Add. And now that this is adding, what we need to do is find our particular chipset and board. So I'm going to go to the source folder, the core folder, and then boards.h. Inside boards.h, I actually have it open to where it is. And this is for the SKR version 1.4, which is the chipset LPC1768. That will be used for our default environment. What I'm going to do is highlight and copy this. Next, I'm going to show you that if you have the turbo version, this is what you would use, and this would be your default environment, being the LPC1769. But seeing how we're not working with that at the moment, I'm going to go over to configuration.h, and I'm going to scroll up to the top here, and I'm going to do a search on motherboard. Inside motherboard, I'm going to highlight the ramps 1.4 and paste over it our board definition which is board underscore BigTreeTech underscore SKR underscore v1 underscore 4. Next, I'm going to change our serial port from 0 to -1. And then I'm going to do a search on the A4988. And down here, this is where our steppers are configured. Currently, they're commented out, so we need to remove the comments. So we're going to do X, then we're going to do Y, then we're going to do Z, and finally we're going to do E0 because these are the most common used steppers. So those are now enabled, but we have a different type of stepper than the default A4988. We're actually using a TMC2209. So we're going to copy that and we're going to paste it for the X and the Y. Now keep in mind that this may invert your stepping. So you may have to search on invert and change your stepping. So we're going to do a quick search on that. So we're going to look for invert, and as you can see down here, we have different ways to invert the axis for the X, the Y, and the Z. You can always change this from a false to a true, and this from a true to a false, but I'll leave that up to you depending upon your stepper. And another way to do it is actually to reverse the connection that you're using for your NEMA17 stepper motors, but we're going to leave that to yourself to figure out. So I'm going to go back and search on the A4988, and we're going to scroll down a little bit and we're going to look for this right here. Now this is default axis steps per unit. Right now they're set to 80, 80, 4,500 for your X, Y, Z, and E0. Now that's the default, so we need to find what we actually need to use. So I'm going to go over to our browser and I'm going to open up a new tab, and I'm going to go to RepRap Calc, and I'm going to open up this link right here, and this will allow us to calculate what we're working with. So I'm going to scroll down because we're not interested in filament, but we are interested in the stepper motor. And as you can see, this is for a belt-driven system. So that would be for your X and your Y axis. The Z axis is down here, and that's a lead screw-driven system. But we're going to go back here and we're going to look at this for a second. Default for a normal NEMA17 stepper motor is 1.8 degrees of step, or 200 rotations per a revolution, and it's default to the A4988 for the stepper. So that would give us a value of 200 if we're using a GT2 belt, and we have 8 teeth on the part that drives the belt, or the pulley. So all we're interested in right now is the actual steppers. So we're going to try 1/32 to see what happens. And as you can see, it jumps to 400. Now the stepper that we're using, being the TMC2209, can do all the way up to 256 of a step. But we're going to try 64 because that's double 32, so that would be 800. So we're going to go back to our configuration over here, and we're going to change the 80 to 2 for these two to 800. So your X and your Y are now 800. So that's basically most of what you need to do for the configuration, but we need to set a couple of things in configuration advanced.h. So what I'm going to do is I'm going to do a search in here for has underscore trinamic. And as you can see down here, we have our X stepper. Because we have it set to 800, it's going to be actually 64 that we need to pick, because 32 would be 1/32 and 64 would be the value that we're looking for. So we need to set that for the X, and we also need to set that for the Y. So I'm going to change that to 64 as well. Now at this point you could basically build and then upload, but I want to show you the debugging that we can use. So I'm going to do a search on monitor _ driver, and this gives us debugging output in our interface, being Pronterface at the moment. So I'm going to remove the comment. And in order to use some of the G codes, we actually have to search on TMC_debug. And we need to remove the comment for this as well. Now that'll give you debugging that you can actually see. Now, like I've said before, the actual sensorless homing currently is not functional in the Marlin firmware because there's a bug open on it. So I'm going to search on sensorless homing just to show you how it would be configured. So it's sensorless _homing, and you would basically remove this comment to enable it, and then you'd have to play with these values to get your sensitivity just right. And right now this doesn't work for me, so I don't want to show it to you. And then there's other functionality up here for hybrid stepping that you can enable if you so choose and experiment with, and other things. So for now, all we're going to do is prepare it to install. So I'm going to click on platform io.ini. And what we need to find here is the default environment, because right now it's defaulted to a Mega 2560. So I'm going to type in LPC 1768 because that's the chipset that we're working with for our default environment. And I'm going to click on the upload button, which will cause this to build or compile and then upload to our board. Now that's slightly different from build or compile right here. So I'm going to click on that. Okay, the first thing I want to show you, after the actual compile and upload took place on the SD card for the SKR version 1.4, you can see there's now a firmware.bin. If we go over to VS Code, we can see that it says that the compile actually succeeded in 2 minutes and 59 seconds. So in order to actually set this up, I've actually configured the board with the power supply that's unplugged, and the USB right now is currently supplying power. So I'm going to remove the power, and then I'm going to move this jumper over the next 2 pins. Then I'm going to reconnect this so there won't be any USB power. In order to load it, I'm actually going to use actual power. So I'm going to remove this, and I'm going to plug this in. And as you can see, it's now starting to flash actual loading of the firmware. So keep in mind that I've actually connected the X and the Y backwards. So this is actually Y and this is X. So we're going to go over to Pronterface now after we check to see that our firmware loaded. So I'm going to click on the actual drive, and as you can see, it's now around the current time that this was recorded. So I'm going to go to my desktop and I'm going to open up Print Run. Then I'm going to open up Pronterface. Inside Pronterface, I'm going to connect, and I'm going to type the G code M122 to give us the status for the stepper drivers. And as you can see, both X and Y are okay. And the 64 that we set up here for microstepping is correct for what we're getting a readout for. So what we're going to do is we're going to first move the Y axis, which is going to be the stepper on the left, And we're going to move that 100 steps to see what happens. As you can see, it moved 100 steps. So now we're going to do the x-axis as well. So notice how quiet they both were. So if you like my tutorial, please like and subscribe. And thank you very much for your time.